In this video, I'll teach you how the tangent graph works and the concept behind it, and then I'll show you how to graph it. So the math side. Now first you should know that instead of 2 pi as the period, like sine and cosine, tangent is just pi. So if you want to put it on a graph, you'll do pi over 2 and negative pi over 2. And that's a period. Tangent graphs always have this shape. Always this shape. So if you draw on the graph, it looks something like that. The reason why it has this weird shape is actually really cool, and it deals with infinity. So you know tangent is sine over cosine. And on the unit circle, sine is the y and cosine is the x. Let's say you started here, right? At 2 pi. And up here is pi over 2. So as you traveled along the unit circle, the y value and the x value are changing, right? As you travel, sine goes from 0 toward 1. And cosine goes from 1 towards 0. Now, you don't have to understand that 100%, but as long as you get the general idea, then you should understand where this shape comes from. Now, how does infinity work? Where does infinity come into play here? Let's say you reached pi over 2, or you reached really close to pi over 2. So sine became 0.99999, and cosine is 0.00001. Right, you're very, very close to pi over 2. Now what happens when you divide a number smaller than 1? It gets bigger. So imagine you have a number and you divide it by an insanely small number. This number is going to be huge. It's going to be insanely big. And it's actually impossible to get to pi over 2 because at that point the number becomes infinity. So that's kind of why the graph shoots up like that. It's not going up exponentially, but it is going up extremely quickly. And if you want just to understand how fast it's going up as you approach pi over 2, let's draw a table. So you have x and you have tan. The value of tan at x0 is 0. At pi over 4, which is here, it's 1. Yeah. At 1.4, it's 1.73. At 1.55, it's 48.08. So just times by 40 already. At 1.5707, I want you to just think what this number here might be. It's 10,381.3. From this tiny difference. This number eventually reaches infinity. So you would write this as 10x approaches infinity as x approaches pi over 2. So tan x is going up to infinity while x moves this way. We can also do the opposite for if you want to write something for going left toward negative pi over 2. It would be tan x approaches negative infinity, which is down this way, as x approaches negative pi over 2 with the little plus. And what this little plus means is basically approaching it from the right. Now I'm going to quickly explain what a vertical asymptote is. So how you spell that is this asymptote. Now vertical asymptotes appear at the ends of the period. So you can imagine an invisible straight line here. Now your tangent graph will never actually touch these lines because it has to reach infinity to touch these lines. but they will get very, very close as you go up on the graph. And vertical asymptotes are good to know because they're used in other graphs too, like the reciprocal functions. Okay, it's time to do some practice examples. So first, let's graph y equals 2 tangent. Now, what you do here, let's say this is normal tangent, right? This is tan x. And here's the asymptotes. Oh, that was messy. Okay, we'll keep it. 2 tan x would end up just being the same as tan x, but you double every single y coordinate. So let's say this is like y3, then tan 2x at this point would be y6. So we basically just made it skinnier. This red one is 2 tan x. Now how about negative tan x? Well, negative tan x is very simple. If this is normal tan x, negative tan x is just backwards. It's just like the sine wave, you just flip it. If you want some extra practice, go join the Discord and I have free problem sheets for every single topic I cover.